In the Philippines, just for 2024 alone, there have been over 15,000 earthquakes. A lot of these earthquakes are small earthquakes, the magnitude 2 and below, hindi natin masyadong nafe-feel, all the way up to more than 7 magnitude earthquakes. Now, the Philippines is a little bit more earthquake prone because we are part of the Pacific Ring of Fire. From what we hear in the media, ang palaging sinasabi lang talaga is magnitude, kung gaano kalakas ang earthquake. But that does not tell the entire story. So how does an engineer really figure out if a structure is safe? Well, we were lucky enough to visit the laboratory of an engineer who is taking this study and concept to the next level and making sure our spaces are as safe as possible. We flew all the way to Pampanga to visit the home of engineer RBS or Rolly Sanchez. If you don't know him, he's one of the top structural engineers here in the Philippines. He's been doing it for over 30 years. And if you've ever been around the Philippines in any big building, most likely you've been to one of his projects. So si Sir RBS is also the engineer for the RISE and tumawag siya sa akin, Slater, I have this laboratory in my home that I want you to see. It's an earthquake table. But this was a full-on laboratory talaga. Let's see the actual earthquake and what it looks like.
Ready, 3, 2, 1.
Makikita mo na nag-ano siya, remove dust dito, sabay-sabay siya.
Yes.
You'll see in the model that there's a lot of movement going on, very irregular, very in line with what happens in the real world.
So these are the data from ETABS, yung software. Those are the earthquake signature. Yan yung mga real earthquake signature.
Ah, okay. Totoong earthquake.
Yes.
So ito is like totoong earthquake na meron tayong data about it and then we pass it on to this machine.
Yes.
So it can simulate that.
Yes, but smaller yung specimen. You have to apply din yung similitude law. But as said, ang crucial part talaga is yung velocity, yung bilis. Kasi you can go slow shaking na ganyan, it won't affect much yung structure. But if you go very fast na ganyan, it would be more damaging.
Yes. Yung simulation natin kanina was about the same as what we would expect in the Philippines, yung the most extreme example.
Yes, kasi around 7 na rin yung
kanina.
loma.
So, one of the first questions that I asked him is, bakit yung earthquake table niya is hindi siya yung nagsishake lang back and forth na akala natin when that's an earthquake is like that, di ba? So apparently, that's just 2 degrees of movement, the forward and back and the left and right, which does not really tell the entire story of what happens with the earthquake. You need this kind of a setup to study for 6 degrees of movement. When you say 6 degrees of freedom, there is the surge, yung front and back na movement. There is the sway, yung left and right na movement. And there is the heave, the up and down movement. There's also the roll, yung pag front and back na rolling. There's also pitch, na yung left and right na rolling. And lastly, there's the yaw, yung pag-ikot talaga or sinasabi ni RBS, yung parang torsion talaga ng building. So this is all aspects of the building that needs to be considered. What impressed me the most is that the level of detail of these models that were used were actually very well considered. So the structures itself, it may look like parang styro lang to, but concrete talaga yun, puti lang yung kulay. Meron din siyang stirrups that mimic how we actually do it on site. So that pag makikita natin may failure point, malalaman natin talaga as much as possible kung bakit. These were all filled with sensors, and not only that, merong nilalagay na bakal to serve as weight to simulate the load of the building when it is fully loaded, when it has furniture, when it has people inside, and even to the point wherein there's a special camera that looks at these models and tracks little dots to see if when it shakes, ano yung mga movement, ano yung mga deflection, and the velocity, and all these datas, makukuha talaga nila to improve their design. By doing the actual model and using earthquakes from around the world, meron tong mga data na ito, earthquake to ng California, ito, earthquake ng Japan on this certain day, this is the name of the earthquake. They can simulate all these different kinds of movements, fast, low, up, down, left, right, and all these magnitudes to see where the weak points are in actuality. Kung saan kailangan i-reinforce natin yung building, saan siya magaling at saan siya weak, and what we can improve on that. It's just a more tangible result. So in the experiment that we ran, meron tayong scale model of the rise versus an ordinary building. And specifically for the rise, nakahagdan siya. And it's kind of wonderful to see it side by side. And makikita natin yung movement, yung deflection, yung sway ng the rise versus an ordinary typical building. Nakikita ko dito, parang exaggerated tong mga movements niya.
Yes.
And I noticed that this was parang nagka-crumple siya ng ganyan. And
Yes.
this was more of acting na sabay-sabay lahat ng mga floors niya.
That's why your idea is a brilliant one. Basically, the same mass, because same area.
Yeah, same mass.
Same ang weight niya. But the fourth story would induce much greater forces than the step-back buildings because it's a shorter height. Center of mass is not that high, so it induces lesser movement. And according to RBS, because of its terracing nature, the rise is actually more effective. So, ang daming mga technical jargon, but if we were really to make it as simple and as easy to understand as possible, it works out like this. So, ito yung earthquake toy nila, Scotty. And then, imagine if this was your tower. So, if the ground starts shaking, the typical tower, vertical tower, nagaganyan yun, di ba? But, if this tower had something to lean on, basically now, the tower is a lot more stable and technically safer. But why do we really need to do it in real life na kaya naman siguro to ng mga computers natin, di ba? I asked RBS this exact question. Actually, the software is also powerful, but the thing is to ensure that it is closer to reality, you have to modify the input data of the software. Let's say if the building moves on the shake table, this real-time data would also move. So you could see where the bending stress is at most.
So this whole simulation thing not only gives data to earthquakes, RBS was mentioning about the lifespan of a building. So ang lifespan ng building, sabihin natin, you subject it to one earthquake, okay siya. But in the course of its life, 100 years or whatever, ilang beses siya mag-earthquake. So just like any cellphone na palaging ginagamit, palaging naaabuso, eventually there will come a time wherein it breaks. So we're not just talking about just surviving one earthquake, it's surviving earthquake over the lifespan of the building as well as the aftershocks of that earthquake, which sometimes, according to RBS, is just as important to study and evaluate as the impact of the earthquakes themselves. Itong mga models na ginawa ni RBS for us, this is for the purposes of this video. They've made one before a long time ago when it comes to designing the rise at Monterrazas. So on top of this, we have this platform and then we have models here. These are actually real rocks in concrete. Meron bang reason for doing it like that?
It's important in the design that you consider the soil structure interaction with response to the building system you're in. Because let's say if your soil is soft, the response of your structure would behave differently.
Yes.
Yeah, so that's one of the reason why when we test, as much as possible, we make it near to the
real site.
Real situation. Let's say if the elevation is higher, it can also amplify the ground motion below. But not as bad as, let's say, if you're on a lower ground, but your soil is liquefiable, wherein very soft yung soil niya, it would
Iba din.
amplify more than the rock.
This is a guy who's so passionate about his work na I asked him, bakit dito mo nilagay yung laboratory mo sa bahay mo? Kasi alam kong meron siyang ibang malaking office sa Ortigas. So sabi niya, oh, this is my weekend project. This is that thing that I like to do during the weekends. Si RBS mismo, he showed me photos that every time that there's a big earthquake around the world, he flies there and inspects the buildings. What were the failure points? What were the things that went wrong? What could be improved? I just wanted to take this moment to say that I was so impressed that this guy is really passionate about what he's doing. And me seeing this man have this kind of passion, the level of detail and commitment to his craft when it comes to design and safety. After this visit, masasabi ko talaga I can definitely sleep more soundly at night knowing that our project is in the right hands. Guys, we're trying to get to 1 million subscribers this year. Hopefully everyone watching will click the subscribe button so that we can hit that number. If you like content like this actually helps us to produce more of these kinds of content. And kailangan ko ring magyabang na meron din akong gold plaque, yung asawa ko meron na. So ako din, please. Anyway, if you like this video, hit like, subscribe, and I'll see you later.